One of the great innovations of the Tinder app was the swipe left and right to select or deselect an image or object, or in their case, a person. And this is what we're going to recreate in this video. So I'm going to do it as a new project. Single view application, and I'll just call it Swipe Demo. So we're going to learn how to drag an object around the screen, and then how to control that a bit more finely so that we can drag from left to right to select or unselect. First off though, I'm going to show you how to add an element or a view to the screen programmatically without actually dragging it into main storyboard. We do that by creating an object, let's call it label. So in this case, it's going to be a UI label. And we're going to create it with a frame. And that's going to be a Core Graphics rectangle, or CG Rect. And we want it roughly in the middle of the screen. So I'm going to make the X coordinate half of the width of the screen, which we get from self.view.bounds.width divided by 2, and I'm going to subtract 100 from that to give us a width of about 200. And similarly for the Y, we're going to use self.view.bounds.height divided by 2 minus 50. It's going to have a height of 100. And the width, as I've said, is going to be 200, and the height is going to be 100. So that should create a rectangle in the middle of the screen to contain our label of 200 by 100. Then we're going to set the label text, just as we're used to doing. I'll call it drag me. And we can set any properties of the label. So text alignment, for example, we can make that ns text alignment dot center. And then we just add that to the view using view dot add subview. And the subview that we're going to add is label. So that's how we add views to the main view or to the screen programmatically. Now we can also add gestures. So I'm going to create a gesture, which is going to be a UI pan gesture recognizer with a target of self, so the view controller. And here we put the method that we want to call when the gesture is recognized. So I'm just going to create that method quickly. I'm going to call it was dragged. And we're going to create this as a selector using self.wasDragged. And you might remember from the map section when we did the long press, we added the colon, which was a way of saying that we wanted information about the gesture to be passed to the new method. So we need to add a gesture recognizer variable here, which is going to have a type of UI pan gesture recognizer. So pan means we're panning across the screen, so moving our finger across the screen or dragging, and then we just clarify that here so it knows to pass that information like that. And then finally we need to set label.user interaction enabled to be true. So by default, a label is not interactive, and we want to make it interactive. We want to be able to drag it round. So we need to make interaction true. So for now, let's just print was dragged in the was dragged method so that we can see that something's happened. And also, let's not forget to add the gesture recognizer of gesture to the label. So all this should do so far is allow us to supposedly drag the label, and ideally we want to be able to drag the label around, but one step at a time. This gesture recognizer should show that we have dragged the label, and we'll see was dragged in the console as a result. So here we go, here's our label, and then you can see if I drag it around, we get this was dragged appearing in the console there. Okay, so that's all well and good, but we're not actually affecting the label itself in any way. So to do that, we need to know where the user has dragged to. And we do that using what's known as a translation. So you may remember translations from your school maths. A translation essentially describes a movement from one point on, in this case, a screen, to another. So it's essentially a vector. And we can get the translation from the gesture recognizer variable using translation in the view. And for now, let's just print the translation and see what it gives us. It should give us the coordinates of where the user has dragged to, which we can then update with the label to move the label in line to where the user has dragged to. So let's see this in action. So if I now drag, you can see there we go. So you can see the relative movement. So it's the translation from the original point to where the user has dragged to. So all we need to do is set the new label coordinates to those of the translation, and we should get this dragging effect for our label. So let's see how we do that. We just take our label and set the center to CG point, and we're going to create that with an X and a Y. So we'll set the X coordinate to self.view.bounds.width divided by 2, and then plus the X coordinate of the translation. So translation.x. And we're talking about the center of the label now, so we don't need to subtract the 100, because this was talking about the left-hand edge. So we can just use that. And then, similar with y, we can use self.view.bounds.height divided by 2 plus translation.y. So this should move the label to exactly where the user is dragging. You may have noticed that we can't use label here because we only defined it in view.didLoad, but we can get it back because it's returned by gesture recognizer. In the view variable. So we can use gesture recognizer.view to generate our label. And we know that gesture recognizer will have a view because that was the view that was dragged. Okay, so let's give this a try. If we now, there we go. So we can drag around and the label is dragged wherever we go. Excellent. So that's a good start. But next we want to work out whether the user has chosen this label or not. And we get that by whether it was dragged to the left or to the right. So all we need to do is check the new coordinates of the label when the drag is finished. And we can check to see if the drag is finished by looking at the gesture recognizer state and see if that's equal to UI gesture recognizer state dot ended. And if that's the case, then the user will have lifted up their finger and made their choice. So we can look at the label center X coordinate and check to see if that's less than, let's say, 100. So 100 pixels from the left of the screen. If that's the case, then we'll print not chosen. And if it's not, then we'll check to see if the label center X is on the right of the screen. So greater than self.view.bounds.width minus 100. So if that's the case, we'll print chosen. And either way, when the drag is finished, we want to move the label back to its starting point. So once again, we'll set label center equal to a CG point with an X of self.view.bounds.width divided by 2 and Y of self.view.bounds.height divided by 2. There we go. So we're going to drag this around, and if we drag it to the left, then it will consider it not chosen. If we drag it to the right, it'll consider it chosen. And either way, once we're finished dragging, it will drag it back to the middle again. So if we were using Tinder for this, then the label would be an image, and then when we drag it, once we're finished, it would start as a new image. So let's just see this in action. So if we drag it to the left, you can see we get not chosen, and it starts again. Drag it to the right, we get chosen. Drag it to somewhere in the middle, and it just starts again and gives us the option to choose once more. Okay, so we're getting there. But if you've ever used Tinder, you'll know that part of its addictiveness is not just about dragging an object around, but it's about the way an object moves. So it slowly turns and resizes itself as you drag to the left and the right. So let's try and replicate that. So we do that using what's known as a transformation. And we can create a couple of transformations. So we'll start by creating a rotation. Now this is going to be a CG affine transform. And then we'll give a rotation angle. Now that rotation angle isn't necessarily quite what you expect. It's not out of 360 degrees. It's in what are known as radians. Now again, you might remember radians from school. You might even have used them since. But essentially, they divide a whole circle into 2 pi radians, which means that 1 radian is about 57 degrees. So let's start by just putting in 1 radian, and we can see what effect that has. And we can then apply a stretch to the rotation, so we get both a rotation and a stretch. So let's see that in action. So we'll create a variable called stretch and rotation, and then we start with our rotation transformation, and then we apply a scale by transformation to that. And for now, let's just make it a little bit smaller. So say 0.9, 0.9. So this stretch and rotation will then do the rotation and the stretch in one go. Finally then, we apply that to our label using label.transform, and then we set that equal to stretch and rotation. Great. So let's quickly see what that does. We should have a rotation of 1 radian, which is about 60 degrees. And then we should also have a small stretch. And because these numbers are less than 1, it will make it smaller by a factor of about 1/10. Here we go. Let's try it out. So we'll drag it around and there we go. So you can see it's rotated and been made smaller. Okay, so that's great. But obviously what we want is our rotation and stretch to depend on how far it is from the center. So if we drag it all the way to the edge, we want it to be more rotated and also smaller. So to do that, we're going to need to know how far the label is from the center of the screen. So let's create a variable called x from center. And that's going to be equal to the label's center's x coordinate, so the horizontal position, minus the center of the screen. So self.view.bounds.width, that's the whole width divided by 2 gives us the center. So now we can change our rotation to use a rotation angle of, say, x from center, and let's try something like divided by 100 and see how that looks. So before we do the stretch, let's just test that out and see what effect that has on our rotation. Here we go. There we go. Okay, so that actually works pretty nicely. I think it's rotating a little too much. We don't really want it to go all the way around like that. So let's halve the rotation amount, and we'll test that in a moment. The scale, the amount that we want to scale it by, is rather more complicated. So let's set up a scale variable. And for the scale, the further it is from the center, the smaller we want the scale to be. So we might do something like 1 divided by the x from center. And that means the further it is from the center, the smaller the scale will be. And then we can use scale to apply our stretch. So let's try that out and see what effect that has. So now if we drag it, okay, so it's having some kind of an effect, but I think it's way too extreme for us. It's scaling it down. It's even turning it upside down over here. Okay, so let's try something like 100 divided by x from center. So that will have the same effect. It will get smaller as it goes more to the right, but because it's starting with 100, it should. Aha. Okay, so that actually looks pretty good when you get all the way to the right. But of course, it's making it bigger when you get very close. And we also have this problem of it turning upside down when we go to the left as well. So, one way to stop it getting bigger is to set the maximum possible scale to be 1. And we can do that by setting the scale to be the minimum of our 100 divided by x from center and 1. And that means that the maximum scale that we'll ever get is 1. Because the scale is taking the minimum out of those two. So either it'll be 1 or it'll be something smaller than 1, which means it will never get bigger than it originally was. So let's try that now. Okay, that actually looks pretty good. So the rotation kicks in right at the beginning. The scale takes a little while, but I think that works pretty nicely. Now, we still have this problem on the left, and the problem comes from if we're on the left of the starting point, then x from center is negative. So you get this strange effect with a negative scale, which turns it upside down and makes it really big as well. So the easiest way to fix that is to use the absolute function, or abs. And what that does is essentially makes the number positive. So even if x from center is negative, this will take 100 divided by x from center and make it positive. So that will do the same scale to the left or the right now. Let's check. So right still looks good, and then left looks good as well. Okay. Fantastic, that's looking great. One thing you might notice is when we do the drag and we let go, if it does go back to the start, then it retains the transformation. So we need to make it so that not only does it set it back to the middle, but it resets the scale and rotation as well. So we can do that easily enough. We just set our rotation back to CG affine transform with a rotation angle of 0. And that will put it the right way up again. And we'll set the stretch and rotation to be a rotation, and then scale by, and then 1, 1 to get it back to its original size. And then we'll apply that to our label in just the same way that we did before. Ah yes, and quite right. We'll need to make these var if we're going to change them later on. Okay, so now it should jump back to the center and change to its original size and rotation state. There we go, so it's rotating nicely. Wonderful, and you can see we've still got this chosen, not chosen, or nothing if they drag it somewhere in the middle. Brilliant. So that's how we get that Tinder drag left and right effect. And now we're ready to build our Tinder app, starting with the login screen.